In this video, I'm going to show you how to square a number. Squaring a number really just consists of multiplying a number by itself. For example, 1 squared can be computed by just 1 times 1, which is just 1. So 1 squared is just 1. Now you might wonder why we call this operation squaring. Surely it must have something to do with a square then. And that is indeed correct. Squaring a number just gives us the area of a geometric square, which has side lengths equal to that number. So 1 squared gives us the area of a square having side lengths 1. And we can see that area is just 1 square unit. Alright, so moving on, 2 squared is just 2 times 2, which is just 4. And geometrically, that corresponds to the area of a square with side lengths 2. So let's go ahead and draw that. Area of a square with side lengths 2. There is 1, 2, 3, 4 square units. 3 squared is just 3 times 3, which is 9. And that corresponds to the area of a square which is 3 by 3 units. Each side length is 3. So let's draw that here. Here's a square with 3 units by 3 units. And if we count up the area of that square, 1, 2, 3, 4, 5, 6, 7, 8, 9 square units. There we go. Lastly, 4 squared is equal to 4 times 4, which is 16. And that corresponds to the area of a 4 by 4 square, having side lengths of 4. So let's draw that out over here. Here's a square having side lengths 4 and 4. And if we count up the area, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 square units. We can even extend this idea of squaring to 0. 0 squared would just be 0 times 0, which is 0. And that also fits in nicely to our geometric interpretation. A square with side lengths of 0 is really just nothing at all, and if we have nothing at all, then the area of that nothing at all is going to be also 0. Alright, let's do 2 more examples using a bit trickier numbers. First of all, we want to compute 8 squared. Well, 8 squared is just 8 times itself, 8 times 8. And do you remember what that's equal to? That's equal to 64. So 8 squared is 64. Okay, and how about the square of a fraction? 1/3 squared. So 1/3 squared is just equal to 1/3 times itself, 1/3 times 1/3. And remember, fraction multiplication, all we have to do is multiply the numerators and the denominators separately. So this is really just 1 times 1 up top, so 1 times 1 is just 1, and then 3 times 3 on the bottom. 3 times 3 is just 9. So 1/3 squared is 1/9. Alright, now let's compute some negative squares. So starting with -1 squared, well, -1 squared is just -1 times itself, -1 times -1. And remember, when we have a negative times a negative, the negatives cancel out and we just have to multiply the digits. So that equals 1 times 1, the negatives cancel out, and 1 times 1 is just 1. So -1 squared is just 1. Likewise, -2 squared is just -2 times itself, -2 times -2. And again, since we have a negative times a negative, the negative signs cancel out and we're just left with the multiplication of 2 times 2, which is just 4. So -2 squared is 4. Moving on, -3 squared is -3 times -3. Again, the negative signs cancel out and we just have 3 times 3, which is just 9. So -3 squared is 9. Lastly, -4 squared is -4 times itself, -4. Again, the negative signs cancel out, so we just have 4 times 4, and the result of that is just 16. So -4 squared is 16. Looking back, we can see the squares of the first 4 negative numbers are the same as the squares of the first 4 positive numbers. 1 is also equal to 1 squared, 4 is also equal to 2 squared, 9 is also equal to 3 squared, and 16 is also equal to 4 squared. And that happens because when we square a negative number, the negative signs cancel out, and we're just left with the positive number times itself. So it's no surprise that negative 1 squared is the same as 1 squared because the negative signs cancel out. Negative 2 squared is the same as 2 squared because the negative signs cancel out. Same idea for negative 3 squared, that's also equal to just positive 3 squared, and negative 4 squared is just equal to positive 4 squared. In general, the square of a negative number is always equal to the square of the corresponding positive number. Here are some final examples. First of all, we want to compute negative 6 squared. Well, negative 6 squared is just negative 6 times negative 6, and we already know that the negatives are going to cancel out, so that'll just be 6 times 6, and 6 times 6 is just 36. So negative 6 squared is just 36. Likewise, if we want to compute negative 1.5 squared, well, negative 1.5 squared is just negative 1.5 times itself, so negative 1.5 times negative 1.5, and the negatives will cancel out, so that's really just 1.5 times 1.5, and to do this we can just set up some columnar multiplication. So how about 1.5 times 1.5? 5 times 5 is 25. Then 5 times 1 is 5, plus 2 is 7. Now we'll stick in our 0, get rid of that 2, clean up for the next round. So 1 times 5 is 5, and then 1 times 1 is 1. And then we just have to add these. So 5 plus 0, 5. 5 plus 7 is 12. So put the 1 up here, bring the 2 down. 1 plus 1 is 2. How many numbers are behind the decimal place? Well, there's one number here, another number there, so 2 numbers behind the decimal place. Move the decimal place over twice. 1, 2, 2.25. So negative 1.5 squared is just 2.25. Now we know how to find the square of a number. In the future, we'll also learn how to perform the opposite operation, known as the square root.